The $89 Harbor Freight generator. When you buy this, are you getting a lot for your money or are you getting a lot of garbage? Well, we're going to find out because I'm going to tear this apart and see how well it's made inside. So far, if you've watched my videos, my experience has not been great with this. The starter mechanism did not work properly out of the box and the voltage was way off and I had to adjust it. Let's start out with the real easy stuff and remove this cover here on the front. Here we can see the intake and the carburetor. The way this works is the air goes in through these two holes, through the air filter, and here to the carburetor. Well, I should say some of it goes through the air filter because this is your air filter, this little piece of foam, but look how poorly that fits in there. There's a significant gap at the top. To speed things up a little bit, let's bust out the power tools. Looks like I have all the screws out for the gas tank. We can pull it off here. It's still connected by a hose. This is just your basic little spring type hose clamp that can be removed with a pair of pliers. Here's the fuel tank itself. It's pretty basic. Two pieces of stamped metal. They're put together, welded here around the edge. One thing I do like is the factory shutoff valve. That's actually a nice feature. I did open the tank up, I don't think I'll be able to show you, and look inside with a flashlight, and there's a little bit of debris, some rust specks in there from the factory. Some people recommend that you put a filter on the fuel line here before it gets to the carburetor. Having looked in there, you know, it's not incredibly dirty inside, but I can see that a filter would not be a bad idea. Next, we will tear into the starter mechanism. Here's the starting mechanism itself. You can see it's pretty basic stamped steel. And then the starter itself, the way it works is when you pull the cord, this plastic pawl pops out and catches the flywheel on the engine and turns it over. This is actually one of the weak spots in this design. If you do a little research, you'll see that these plastic pawls do break sometimes. And if that happens, you're basically out of luck and you have to buy a whole new starting mechanism. So for those of you who are thinking about buying one of these, be careful with this starting mechanism. Don't just go yanking on it willy-nilly. Make sure the pawl is properly engaged before you really pull on the cord. I just went to remove the spark plug boot, and this is one of the areas where they kind of cheaped out on this. All that you have connecting the wire to the spark plug is this little spring coil and these two little spikes that stick into the wire inside the boot here. So it's very easy when you're trying to remove the spark plug wire to end up pulling this out of the wire and pulling off the boot itself. Some people online recommend replacing all this with an aftermarket spark plug boot that's significantly better than this whole design. This is your basic single-cylinder air-cooled small engine. You have the cylinder jug here, the head here, obviously the spark plug. Hopefully you can see this down in there. That is the bottom of the cylinder, and it has what looks like a foundry mark, and it appears to say "Hang You." I've done a little Googling, and I haven't found anything specific about if that's just a parts supplier, if that's the company that supplied the mold for the cylinder, or if that's the company that made the generator. There are various different companies with "Hang You" in the name, some of which make molds for casting parts, some of which make small engine parts. So that's at least a little bit of a clue of who supplied this generator, or at least supplied some of the parts. Here's a look at the flywheel, and this has another hint about who's supplying at least some of the parts. You can see here it says BOER. I Googled that, and there's a company, I'm sure I'm going to butcher this name, called Zhejiang Bohr Electromechanical in China. On their website, it shows that they supply outdoor equipment like lawnmowers, tillers, but it does not show them supplying generators. However, they also supply parts, including things like flywheels, it shows on their website, pulleys, and other kind of parts like that. So what it looks to me like is they just supplied this pulley that was used when this generator was built. Another thing to note is the casting work on this pulley is significantly cleaner and significantly sharper than it is over here on the cylinder and the head. And you can tell just by looking at the name. It's really easy to read, crisp letters, very well done, whereas the name Hang You on the cylinder is a lot rougher, a lot more difficult to read. Here we are behind the flywheel. One thing I can say is the work in here looks good and looks significantly better than it does on the cylinder and the head here. You can see with all the different details here, this is a pretty complex part. I don't see any voids, I don't see too much casting flash or any other issues like that. Looking at the seal here on the crankshaft, the size is 30 millimeter bore, 20 millimeter shaft, and 7 millimeter width. I don't see an obvious brand name. I see the markings MAK and TC. I was poking around a little bit more, and TC, this marking here, indicates the type of lip seal this uses. But MAK, I cannot find anything as far as that goes. There is a seal maker called NAK, but this is clearly MAK, so I don't know if this is a no-name seal or that's some kind of marking that I can't decipher. Here's the carb off of this. I did not see really any markings except for this AP145-65. Googling that does not turn anything up, so I don't exactly know who made this. However, there is the manufacturer mark. I did a little digging and I can't figure out what company that is. So if anyone recognizes that mark, let me know. Another thing about this, really cheap rubber fuel line here. Replacing this with something better quality would not be a bad idea. Here's the wiring for the generator. It's pretty simple. You have the coil here, the capacitor here, you have the switch here. This wiring here goes up to the outlet in the front. All your electrical connections are these basic little spade connectors. They're crimped on. I don't see any solder or anything on them, but they do have at least these plastic little condoms that go over them to offer a tiny bit of weather protection. I looked around on the plastic. I don't see any markings that indicate what it is, but it's obviously something cheap and pretty flimsy. Here we have the capacitor. No brand name or anything that I can see on it. At least it's potted here, but nothing fancy about this. Here's a look at the breaker itself. Zhongzhui, I guess, is the brand name. I'm probably pronouncing that horribly. This is an 8 amp breaker, so it says 700 watts running load on this generator, 900 watts peak. But if it's 8 amp, that means you probably wouldn't blow the breaker until you hit 960 watts, assuming that's accurate. Let's get in here and look at the back side of the socket. Here's the electrical socket. It's basically what you'd find in your house. One thing that's interesting is this is a 20 amp socket. That's obvious from the little cutout here on the side. But why would they put a 20 amp socket in this generator when it could never power something close to 20 amps? I guess that's just a mystery for the engineers who made this. Finally, at least, we have something with a brand name on it, Uchen, U-C-H-E-N. I Googled this. This is an electrical parts company in China. They make sockets, electrical connectors, all kinds of various things. They are a joint venture, their website says, between a Chinese company and a foreign company, but I can't find anything that says what that foreign company is. As far as build quality on this thing, I mean, it's basic. It's an electrical socket. You can't screw that up too much. So at least as far as the molding on the plastic goes and the connections, everything looks fine. Another note, it claims to actually be UL listed. Any of you with a really sharp eye might have noticed that the spark plug I have installed in this generator is an NGK, but that's not the original one. This is the original one. It's a Torch brand, which is a Chinese company. You can see it came with some nice rust right there from the factory. Many people online recommend replacing this plug because they say it's not especially good. This is where the carburetor mounts to the generator. You can see they machine a flat spot here into the aluminum housing, then they bolt this adapter down, and then the carburetor screws to that. You can also see they decided to seal it up with both a paper gasket and silicone, and boy, they did not scrimp on the silicone. Check that out. This is on the actual electrical generating side of the generator. Here's another mystery logo cast into the housing. Anyone recognize that? You know, my Googling hasn't turned up any results. It looks like you have to remove the muffler to get this back part of the housing off. Okay, now we're making some progress. Well, I thought we were. All right, I managed to get the back of the cover off. What was happening is it was just stuck. There's a little bearing housing here that is just kind of a light press fit on this bearing on the back of the rotor. Here's the back cover I just took off. This is pretty lightweight. I think it's a little bit flimsy, but you know, they reinforced the legs here, the parts that would actually be taking the beating. So overall, maybe it's not that bad. On the top here, we have a 6203 2RS bearing. 6203 is a really common size. 2RS means it has these black rubber seals on both sides. And it says JP. That's the only other marking I can see so far. You know, I Googled that. That's not a brand I recognize. I see a bearing distributor with that name out of India, but I'm not 100% sure on the brand of this. We have a 10mm screw here on the end of the rotor. I think this is the first screw I found on this that isn't 8mm. Turns out I need something with a little more punch than that air ratchet. Well, unfortunately, I have some not so great news here. I am having a hell of a time trying to get the rotor out of this thing. It is really stuck where the rotor connects to the crankshaft. I've been beating on it with a dead blow mallet trying to get it apart with no luck. I don't want to destroy anything trying to get it apart, since in theory this should still work when I'm done. So we're just going to have to see what we can see here, but luckily we can still see quite a bit. Here we have a look at the stator. This is made with a bunch of punched steel laminations. They're obviously stacked up here and then welded in several spots with a not great but not the worst weld I've ever seen, holding all of these together into a solid block. Looking at the windings here, one thing that's interesting, and I'll admit that I'm no electrical expert, so if anyone knows, tell me why this may be. There are two different gauges of wires in the field winding here. We have some smaller ones that I measured at 20 gauge, and some thicker ones here around the edges that I measured at 17 or 18 gauge. The assembly on this is basic, but nothing terrible that I see. Obviously, they use the high-tech string method of holding everything together. You can see some insulators here where the wires go into the body of the stator itself. Here we are looking through the fan blades at the rotor. You can see the windings themselves have these kind of specks in them, and they're awfully shiny. And that's because the rotor, after it was all wound with wire, the entire thing was dipped in an adhesive, basically a glue that once it hardens, it holds everything together. That helps prevent things from vibrating around when this is in use, because, as you know, vibrating wires, they can work harden and break loose, and that causes a failure. Here you can see where the wires terminate and are soldered. Not the prettiest job here, but definitely functional. The rotor itself is made up of this steel shaft in here, which is turned on a lathe. Then you have this basic plastic body here that's pressed on, and that's what actually holds the windings. I was kind of debating how deep to go into this thing, but you know, we've got this far. Might as well keep going. Here's the head. This is our head gasket, a really thin stamped steel metal gasket, if I can get it off here. One correction here, this is an aluminum gasket, not steel. That makes sense now that I think about it, because it's easier to deform when you're torquing down the head, which is what actually creates your seal between the head and the cylinder here. Here's another hint on a part supplier. See this kind of stylized G, I think it is? This is on the bottom side of the aluminum head. This marking is also on another part that I showed you earlier on the body of the generator, but it's different from the company that made the flywheel for this. So if anyone recognizes that logo, tell me who it is. Here we have the head itself. As I mentioned, it's aluminum. This is pretty well made. You can see this is a pretty intricate casting with all the fins and everything. And overall, it's well formed. It looks good. There's not a lot of casting flash or anything. It's machined here on this face where it seals to the cylinder. All that looks good. The threads look pretty good for the spark plug. So overall, nothing wrong with this. Now we can take off the cylinder itself. As I mentioned earlier, we've got a casting mark here. It says Hangyu, H-A-N-G-Y-U, and 63 centimeters. This is a 63cc engine. The work on this is not nearly as pretty as we've seen on some of the other parts. We have a lot more casting flash. The machine work here on this flange is not that great. So simply not as nicely done as some of the other parts we've seen, at least when it comes to cosmetics. I also noticed this in the cylinder. We've got some scoring already, and this has not been used very much. I probably only have a couple hours total on this generator. That's not very encouraging. I've seen some people online recommend lubricating this with a little bit of two-stroke oil through the spark plug hole before the first time you start it up, since there won't be any two-stroke in there, oil in it from the factory. Having seen this, I would say that would probably be a good idea. I'm going to split the case here so that we can take a better look at the crankshaft and everything. To do that, you have to remove this plate that the carburetor mounts to. That silicone is really holding that on there. There's the reed valves and everything. Here's the machined area where that mounting plate connects to the two halves of the case. You can see why they slather this up with both silicone and use a gasket, and that's to protect from leaks around the joint here where the two cases meet. I was expecting, after seeing that silicone goobered on there, that this was a really rough joint, but actually now that I get in here and feel it, it's not too bad. We are getting close to splitting this case. There are just a few more screws here to take out. If I got everything, this case should just come apart. It didn't come apart very daintily, but here it is. And as we saw on the other side, the casting on this housing looks good. It's also milled here on these surfaces where they use RTV silicone to seal it up. And everything here looks pretty good. I very carefully punched out the bearing in that housing. This is the bearing that supports one side of the crankshaft. There's a corresponding bearing on the other side. And it paid off to punch it out because we see some markings here. This says 6004. That's the bearing size. You can see this is an open bearing. What that means is all the lubrication for this bearing comes from the exhaust. And that's because this is a two-stroke motor. So you put oil into the gasoline after it's burned. It flows through the bottom end of the engine to lubricate everything, and that's the only way this bearing is lubricated. The other marking here is what I assume is the brand name. It looks like it says ONO. I'm pretty familiar with bearing brands, and I do not recognize that, and I Googled it and also could not come up with any information about this company. So do you recognize this bearing brand name? Because I do not. It would be a little more encouraging if we could see a country of origin on this bearing or a brand name that we recognized or could easily find some information on. I should add, I don't think I've read much about these bearings failing prematurely, so maybe this is a decent quality piece. The reason you want a quality bearing here is because this is supporting the crankshaft. These take a lot of abuse, and if this fails early, that's basically the end of your engine and it's rebuild time. Looking at the piston itself, it's aluminum. You can tell by the machine marks it has been turned to form the final outside diameter. On the exterior, the machine work all looks good, but you can see here some scuffing already starting on the piston. As we saw earlier, there was some scoring in the cylinder. That's not very encouraging because this is almost brand new, and again makes me think lubricating it before you fire it up for the first time would be a good idea. Here we are looking at the piston rod. You can see some discoloration in the metal here. I think that's because of the different heat treatments they've done in different areas of the piston rod. It's ground up here at the top where it goes by the piston pin. Everything looks good there. Down on the bottom it has some grinding to get the casting flash off. That all looks fine. I Googled this part number here on the piston rod and came up with nothing. I was hoping that might give us a hint who made the part or made the engine, but I didn't find anything. Looking at the crankshaft itself here, it's cast. Then there are a couple different machining processes used. You can see here these machine marks going around like this because this has been turned in a lathe. But here on the lip, it's flat and smooth because they ground this surface. The machine work is a little bit coarse on this. It's not as fine as we've seen on some of the other parts, but it's consistent and it's probably fine for this application. So what did we learn from ripping this thing apart? Well, I would say overall it has decent bones. The build quality on the body and the internals seems pretty good, especially for the price, only 89 bucks. But they really cheaped out on some of the accessories like the spark plug wire and the fuel hose. That's all really bottom shelf stuff. The starter mechanism is not very robust, and I would also like to see a name brand bearing in the bottom end. Also on mine, the quality control sucked. This was set at 144 volts from the factory, and the starter mechanism was improperly assembled. So overall, this generator does not have a lot of power, but you are getting a lot for your money. If it fits your needs, it's a pretty good bargain, but be ready to give it a good once over and replace a couple of the cheaper parts as needed. And be careful with that starter mechanism. Thanks for watching. Hit the like button if you like this video and subscribe so you can see my new videos when they come out.